Welcome YouTubers to another episode in my Grammar Hero series. In today's video, I'm going to be working out mathematics knowledge practice test problems from a website called ASVABpracticetest.com. Before you watch this video, I strongly encourage you to visit that website and try these problems on your own. And in case this is your first time finding my YouTube channel, also quickly want to mention that I created my own website called mastertheasvab.com. There you can sign up for a basic, free, and premium account, which will enable you to take about 11 different practice tests. All that said, let's get started with today's video. Question number 1 says simplify. It's x to the 6th times x to the 5th. In order to do this problem, you have to know the laws of exponents. Specifically, you have to know this one. A to the m times a to the n is equal to a to the m plus n. As you can see, that's what we have in this case. So we have x to the 6th times x to the 5th. So that's simply going to become x to the 6 plus 5, which is x to the 11th. Okay, so that's this one. Again, on my website, I have a formula sheet which includes all of the laws of exponents you need to know for the mathematics knowledge subtest. So when you get a chance, go ahead and create an account so you can look at that. But that's this one. Let's go ahead and move on to number 2. And rather than working through these problems fairly quickly, I'm going to take my time and explain every single thing I do. So that way, if you haven't seen this material in a long time, you should be able to pick it up just by watching what I'm doing. Question number 2 says solve for x. We have 3 times x plus 1 plus 5 times x minus 2 plus 7. So let me go ahead and write this problem down. On the ASVAB, you're not allowed to use a calculator, but you will be given a pencil and paper. Generally, I always write the problems down on my piece of paper. That way, if they require a lot of work, I already have them set up. So that's what I'm going to do off to the right here. Again, 3 times x plus 1 equals 5 x minus 2 plus 7. So what I'm going to do is distribute this 3 to the x as well as to the 1. So 3 times x is 3x. 3 times 1 is just 3. And likewise, I'm going to do the same thing here. 5 times x, 5x. 5 times negative 2 is negative 10. And then just plus 7. Again, we're trying to solve for x. So in other words, we want to move all the x's to one side of the equation and all the whole numbers to the other side of the equation. So in order to do that, the first thing I'm going to do is move 5x to this side by subtracting 5x from both sides. 5x minus 5x is nothing. 3x minus 5x is negative 2x. We still have this plus 3 equals negative 10 plus 7. And as you can see, I don't quite have all the x's and whole numbers on different sides of the equal sign. So to do that, I'm going to have to subtract 3 from both sides. 3 minus 3 is 0. So this leaves me with negative 2x equals negative 10 plus 7 minus 3. Let's go ahead and combine these like terms. So we got negative 2x equals negative 10 plus 7 is negative 10 plus 7 is negative 3 minus 3. Okay, and so we have negative 2x equals negative 3 minus 3, which is negative 6. Let's divide both sides by negative 2 to get x by itself. This crosses out. We're left with x equals negative 6 divided by negative 2, which is going to be a positive 3. So in this case, we know the answer is positive 3. In case you're wondering why negative 6 divided by negative 2 is positive, that's because of the signs chart. Let me go ahead and write that in case you haven't seen it in a while. And the signs chart, as I'm going to point out in just a minute, is applicable to both multiplication as well as division. And the way it works is, here's your first term, here's your second term, here's your product slash quotient. Again, product refers to multiplication, quotient refers to division. In this case, we have negative 6, that's negative, divided by negative 2, that's negative. So we know the quotient is going to be positive. Okay? So that's that one. Again, you have to know the signs chart like the back of your hand. It's fairly easy to use. At some point, if you use it enough, you'll have it memorized and you won't have to write this down every time. But again, first term, second term, and this third column tells you what your product or your quotient is going to be. A lot of algebra for that problem, but nothing too hard. Let's go ahead and move on to number 3. All right, number 3 says if y equals 3ab plus 2b to the third, what is y when a equals 1 and b equals 2? So we basically just have to plug in a where we see a in this equation and b where we see b. But that said, as I always like to do, let's go ahead and transcribe the problem. And take your time as you do this, because this is where people usually make the most mistakes. We have 3ab plus 2b to the third. Now let's plug things in accordingly. Y equals 3. A is 1. B is 2. Plus 2 times, again, b is 2. And that's raised to the third power. Let's keep working this out. 3 times 2 times 1 is just 6. Again, 3 times 2 is 6. Anything times 1 is just itself. 2 to the third is the same as this. 2 to the third is the same as 2 times 2 times 2, which equals 2 times 2 is 4, times 2 is 8. So 2 to the third is 8. Of course, we have a 2 there, so this is 2 times 8. Let's keep working it out. 6 plus 2 times 8 is 16. 6 plus 16 is 22. And that's that one. Okay. So again, just some basic algebra, including with some exponents. Let's go ahead and see what number 4 looks like. Number 4 says a rectangle is cut in half to create 2 squares that each has an area of 25. What is the perimeter of the original rectangle? So let's see if I can draw a rectangle. It's a pretty good rectangle, if I don't say so myself. We're going to try to cut it in half to form 2 perfect squares. Again, just to show you this, the area of a square is equal to side times side. And in a square, all the sides are equivalent. In this case, we know the area of the squares are 25. So again, to get 25, and that says ASS there, I don't know if you noticed it. To get an area of 25, we're going to do 5 times 5, which means that these squares have all the sides equal to 5. Okay. So putting that onto this diagram, it means this is equal to 5, 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 and it's irrelevant, but this is also equal to 5 for both squares. Now to find the perimeter of the rectangle, you add up the width plus the length plus the length. Oh, I wrote width there. What am I thinking? And again, let me do a small diagram in case you don't follow. Width, length, length. That is, to find the perimeter of the rectangle, you just add up all the sides. The width is 5, as we can see. The width over here is 5. The length is 5 plus 5, or 10. And the length on the bottom is 10. So we have 5 plus 5, which is 10. 10 plus 10 is 20, plus 10 is 30. So I know the perimeter, or the perimeter of this rectangle is 30. Again, to find it, I had to know that the area of a square is side times side. Since the area of the square is 25, that means each side of the square is equivalent to 5. And then I plugged that into the rectangle diagram accordingly and just added up all the sides. So that's that one, pretty basic. Let's go to question number 5. And you should feel as if the mathematics knowledge subtest is easier than the arithmetic reasoning subtest. The reason being is there's not as many word problems on the mathematics knowledge subtest. It's basically very basic algebra, whereas the arithmetic reasoning subtest includes algebra, but more often than not, it frames all the questions in word problems. Okay, so question 5 says 44 is 80% of what number? So this is the way I approach these numbers, or these questions. 44 is 0.8 of what number? And I represent that unknown number of x. 0.8 is the same as 80%. So now I'm just doing a one-step algebra problem where I'm solving for x. To solve for x, I'm going to divide both sides by 8, or 0.8. This is going to cross out. I'm going to be left with x equals 44 over 0.8. Now, you regard all fractions as long division, namely 44 over 0.8 is the same as 44 divided by 8. So that's going to, as I just mentioned, going to be 44 divided by 0.8. Now, as you can see, we're doing long division, albeit with a decimal outside this division bracket, which we can't do. In order to do this problem, I have to shift this decimal place one time to make 0.8 just 8. And since I shifted this decimal outside the division bracket, I'm going to take this decimal, which is right there, and shift it one time inside the division bracket to keep proportionality. So in reality, I'm working out this problem. 440 divided by 8. Now the question is, how many times does 4 go into 8? 4 is too small. How many times does 8 go into 44? It's going to be 5 times without going over. 8 times 5 is 40, so we're going to subtract. 44 minus 40 is 4. We drop down this 0. Now the question is, how many times does 8 go into 40? It's going to be 5 times. 8 times 5 is 40. 40 minus 40 is 0, so we can see there's going to be no remainder. So 44 divided by 0.8, as we just worked out, is going to be 55 with no remainder. Okay, so that's that one. Again, there's nothing too tricky about the mathematics knowledge subtest, as long as you're pretty good with addition, subtraction, multiplication, and division, including with decimals and fractions, and you're good with algebra as well as geometry. You should breeze through this section of the test. That's pretty common. Number 6 says, what is the value of the expression given below? 26 minus 7 times 3 plus 5 divided by 4 plus 2. Whenever you see something jumbled up like this, you should know immediately that you're going to have to use PEMDAS to solve the problem. PEMDAS refers to the order in which you work out these problems. That is, you work on parentheses first, you work exponents next, you do multiplication and division from left to right, and you do addition and subtraction from left to right. So as we can see, everything's jumbled up. To impose order on this question, we're going to work it out according to PEMDAS. Again, please excuse my dear Aunt Sally if that's how you have to memorize it. But again, to get started, I'm simply going to transcribe the problem over here so I can have some space. Okay, so according to PEMDAS, the first thing I'm looking for is parentheses. I can see that I do have parentheses, namely 3 plus 5. So let's work that out first. 26 minus 7 times, let's work this out. 3 plus 5 is 8. Okay, so let's just write that down. Divided by 4 plus 2. So I got rid of the parentheses. Now I'm looking through what I have left for exponents to work out. I don't see any, so we're going to skip that. Now I'm looking for multiplication and division from left to right. I have subtraction, multiplication, division, and addition. Again, multiplication and division from left to right. I have multiplication there, so I'm going to do that first. 26, 7 times 8 is 56, so this is going to be minus 56 divided by 4 plus 2. So I did multiplication. As we can see, we do have division left. So let's go ahead and work on that. 26 minus 56. Oh, let me not write that down. Minus 56 divided by 4. Let's work that off to the side. 56 divided by 4. There's no shame in doing the work off to the side so you don't make a mistake. 4 goes into 5 one time without going over. 1 times 4 is 4. Subtract. 5 minus 4 is 1. Drop down this 6. 4 goes into 16 4 times without going over. 4 times 4 is 16, so we can see there's no remainder. Ergo, 56 divided by 4 is 14. Again, this is plus 2. So we did division. Now we're working addition and subtraction from left to right. We can see we have subtraction first and then addition. So again, we're working from left to right. In other words, addition and subtraction are equivalent. Whatever shows up first from left to right, that's what we're going to do first. So as you can see, subtraction showed up first, namely 26 minus 14. Let's work on that. 26 minus 14 is going to be 12 plus 2. So we did our subtraction. And the only thing we have left is addition. 12 plus 2 is 14. Okay? So again, whenever you see problems that are jumbled like this, right away know you're going to need PEMDAS to impose order on this question. And specifically, you're going to do parentheses first, exponents next. Multiplication and division are treated as equals, in which case you work them out from left to right as they appear. Addition and subtraction likewise are equals, and you work them out from left to right as they appear in the problem. But that's that one. I like those problems. They're pretty straightforward once you get used to using PEMDAS. And let's move on to question number 7. Question 7 is a pretty typical ASVAB question. It says, which of the following numbers is the greatest? As you can see, we have decimals and fractions. So the goal here is either to convert the fractions to decimals or vice versa, the fractions to decimals. So let's go ahead and convert fractions to decimals. 2/3 we should know is the same as 0.6666. Repeat it. And in case you didn't know that, you can do 2 divided by 3. You ask yourself, does 2 go into 3? It doesn't. It's too small. You have to add a 0. When you add that 0, you have to put up a decimal. 3 goes into 20 6 times without going over. 6 times 3 is 18. 20 minus 18 is 2. Does 3 go into 2? No, you have to add a 0. 3 goes into 26 times without going over. 3 times 6 is 18. And as you can see, this is going to repeat over and over again, which is why we know it's 0.66666 repeated. Okay, 0.6 is just 0.6. We should know that 0.66 repeated is greater than 0.6. 0.08 we should know is smaller than both of those. Again, if I were to say Do you want $5.08 or $5.66? Which one would you take? You would take $5.66 because it's greater. So always think about the decimal places in cents and you'll never go wrong. Do you want 8 cents? Do you want 60 cents? Or do you want 66 cents? Clearly, you want the most you can get. Now, I want to convert 13 over 22 to a decimal so we can see if it's going to be greater than 0.66 repeated. 13 divided by 22. Now I'm asking myself, how many times does 22 go into 13? It doesn't. I have to add a 0. By adding that 0, I bring up a decimal. And we can see that now we're asking ourselves, how many times does 22 go in 130? And that answer is going to be 5 times. 22 times 5 gets you 5 times 2 is 10, carry the 1, 5 times 2 is 10, plus 1 is 11. So 22 times 5 gets you 110. So I know 13 over 22 is going to be 0.5x. Again, do you want 66 cents, 60 cents, 8 cents, or 50 cents? Clearly you want 66 cents, so the biggest one, the biggest decimal here is 2/3, which is the same as 0.66 repeated. Okay, so that's that one. And again, you got to be comfortable going from decimals to fractions and vice versa. So that was a good practice problem of that. Let's go ahead and move on. All right, question 8 says, in the figure below, lines D and F are parallel and the angle measures are given. What is the value of x? So as we can see, x is right there. D and F, which are right here and here respectively, are parallel. So we're going to have to use the two angle measures that they gave us to figure out what x is. So there's a few things you need to know. Whenever you have two angles and they make a straight line, they're always going to add up to 180 degrees. All triangles add up to 180 degrees, and all quadrilaterals, which are squares and anything with 4 sides, add up to 360 degrees. Okay? In addition, we have to know what vertical angles are. So like if we have two lines that look like this, and let's say this angle was 30 degrees. This angle down here would be its vertical angle, and it would have the same measurement. Similarly, if this was 55 degrees, this angle over here would be its vertical angle, so that would also be 55 degrees. So let's deal with the vertical angles first, and then we'll go from there. So as we can see, these two angles are vertical angles. So if this one's 120, this one's 120. This angle and this angle are vertical angles. So if that one's 35, this one's 35. Okay? Now let's use the fact that all angles that form a straight line add up to 180 degrees. As we can see, we have a straight line right here. If this angle is 120 degrees, this one is simply going to be 60 degrees. Again, 60 plus 120 is going to be 180. Okay? And similarly, we can see that since these are parallel lines, if this angle is 120, this one's also going to be 120 degrees. Okay? And again, we can use this fact right here. This is also a straight line, so this is going to be 60 degrees. Okay? So what else can we use to figure this out? Well, I used vertical angles already, so there's nothing left to do there. I used this information that two angles that form a straight line add up to 180 degrees. I used that, so we're done with that. Now you can see that I have a triangle here that looks like this. Let me try to draw it for you. And we have 35 degrees there and 60 degrees here. As I mentioned at the beginning of this problem, all triangles add to 180 degrees. So we have 35 plus 60. And we want to know what this angle is going to be. So let me start that over. That was a bad explanation there. 35 degrees plus 60 degrees plus x degrees we know is going to be 180. And again, that's this triangle right here I'm referring to. 35 plus 60 is 95 degrees plus x degrees is going to be 180 degrees. Let's subtract 95 from both sides. 180 minus 95. 0 minus 5 we can't do. We have to borrow. This becomes 7. This becomes 10. 10 minus 5 is 5. 7 minus 9 we can't do. We have to borrow. This becomes 0. This becomes 1. 17 minus 9 is going to be 8. So this third angle of this triangle is going to be 85 degrees. So this is 85 degrees. And as we can see, we have these exterior angles. This one's 60. This one's 60. This one's 85. This one's also going to be 85, which is our answer. There's more than one way to do this problem, but you have to use multiple steps and multiple instances of geometry to get your way to this 85 degrees. So that's that one. I don't like these problems because they can get very tedious, but that's how I decided to solve this one. Again, there's multiple ways to do that problem. So let's go ahead and move on to question number 9. How did I get it wrong? I didn't even do it yet. Okay, let's work it out. Question 9 says 7y squared plus 3xy minus 9 minus 2y squared plus 3xy minus 5. So as you know, the first thing I like to do is to rewrite the problem. We have 7y squared plus 3xy minus 9 minus 2y squared, and I'm going to need more space. Let me rewrite that one. We have 7y squared plus 3xy minus 9, that's all in parentheses, minus 2y squared plus 3xy minus 5. The key to doing this problem is to distribute this negative to all these terms. Technically, there's a negative 1 right there, so I'm going to distribute it there, there, and there. That is, I'm going to multiply it by 2y squared, 3xy, and negative 5, and then I'm going to combine like terms. So again, we're going to have 7y squared plus 3xy minus 9. Let's distribute this negative 1. Negative 1 times 2y squared is negative 2y squared minus 3xy. Again, negative 1 times 3xy is negative 3xy. Negative 1 times 5 is going to be positive 5. Negative times negative is positive. Let's combine like terms. 7y squared minus 2y squared. That's going to leave us with 5y squared. That gets rid of those. 3xy minus 3xy is nothing, so that gets rid of those. Negative 9 plus 5 is negative 4. So we can see the answer is 5y squared minus 4. Okay, so that's number 9. Let's go ahead and move on to number 10. Okay. Number 10 says 6.6 times 10 to the negative 4. As you know, I like to write things down first. 6.6 times 10 to the negative 4. This is scientific notation, and in essence, all you have to do to solve this one is move the decimal place left or right accordingly. Since the exponent is -4, what you're going to do is take this decimal and shift it to the left 4 times. 1, 2, 3, 4. Fill in your zeros. So 6.6 times 10 to the -4 is 0.0066, which is this one. Okay, if this 4 was positive, you would take this decimal and move it to the right 4. So that's that one. And the software I'm using to do these problems is acting up, so just bear with me here. Let's go ahead and move on to, I think that was number 10, so let's check number 11. Yep. Alright, number 11 says, what is the value of this numerical expression? So we have 6 squared plus 8 squared. Let's go ahead and work this out further. 6 squared is the same as 6 times 6, which is 36, plus 8 times 8, which is 64. 36 plus 64, I know off the top of my head, is 100 because I've seen this so much. But if we do it off to the side, I'll show you that that is in fact the case. 4 plus 6 is 10, carry the 1. 6 plus 3 is 9, plus 1 is 10. Okay? Square root of 100, we should know, is just 10. So the answer to this problem is just 10. Okay, so that was that one. Let's move on to number 12. Number 12 says list A consists of the numbers 2, 9, 5, 1, and 13. And list B consists of the numbers 7, 4, 12, 15, 18. If the two lists are combined, what is the median of the combined list? Before we combine these lists, let's just talk about the median in general. If I give you these numbers, 1, 3, 6, and 10, and asked you to find the median, you would know you're trying to find the middle number, so you'd cross 1 off on this side, 1 off on this side, and as you can see, you can't cross each of these off because that'll leave you with nothing. Instead, you have to find the average of these two, so you would do 3 plus 6 divided by 2. 3 plus 6 is 9 over 2. 9 divided by 2 is 4.5. We're going to apply the same concept to this problem. So in order to find the median, you're going to order the numbers from least to greatest. I can see 1, so let's start with 1. Cross that out. I can see a 2. 2. We don't have a 3. I see a 4 next. Let's cross that out. Is there a 5? There's a 5 right there. 6, no 6. 7's right there. 8, no 8. Got a 9. Got 12, 13, 15, 18. 12, 13, 15, and 18. So I just combine both of those lists. Now as I did up here, I'm going to start crossing things off. One at the small end, one at the large end. Cross this one, 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 this one. As you can see, as in this problem, we have 2 numbers left, so we have to take the average of those. 7 plus 9 divided by 2. 7 plus 9 is 16 over 2. 16 divided by 2 is just 8. So the answer to this question is 8. Again, we combine the list into one big list. Again, we can call this list C if we wanted to. And then we just crossed 1 off at each end until we got the last 1 or 2. In this case, we had 2, so we had to find the average by adding them up and dividing by 2. Okay, let's go ahead and move on to number 13. Number 13 says simplify the factorial Let me point out that whenever you see something followed by an exclamation point, this is all you do with this. So let's say I gave you 4 exclamation point. You just do 4 times 3 times 2 times 1. That's all you do. Let's say I gave you 5 exclamation point. That would be 5 times 3 times 2 times 1. Okay? Oh, I missed a 4 there. Let me redo that. 5 factorial would be 5 times 4 times 3 times 2 times 1. 6 factorial is going to be 6 times 5 times 4 times 3 times 2 times 1. Okay, so let's work this out. 6 times 5 is 30. 30 times 4 is 120. 120 times 3, let's work that off to the side. 3 times 0 is 0. 2 times 3 is 6. 3 times 1 is 3. So this is 360. 360 times 2. If you need to, you can work that off to the side, but you should know it's 720. 2 times 0 is 0. 2 times 6 is 12. Carry the 1. 3 times 2 is 6 plus 1 is 7. So this gets us 720. 720 times 1 is just itself. So 6 factorial is just 720. Again, get used to reading this as 6 factorial. And all you do is multiply all the numbers leading up to 6. 6 times 5 times 4 times 3 times 2 times 1. That's all you do for those problems. So that was number 13. Let's do 14. Okay, number 14 says negative 3 to the third, which is the same as this. Negative 3 times negative 3 times negative 3. And we can use our signs chart to help us solve this one if we need to. Again, signs chart is, let me make a quick one for you in case you do need it. A positive times a positive is a positive. A positive times a negative is a negative. A negative times a positive is a negative. And a negative times a negative is a positive. So let's work this out one step at a time. Negative 3 times negative 3. We have a negative times a negative, so we know the result's going to be positive. Negative 3 times negative 3 specifically is going to be positive 9 times negative 3. Now we have positive 9 times negative 3, so we know the product is going to be negative. 9 times 3 is negative 27. Okay? Another easy way to remember this is like this. A negative raised to odd power is always going to be negative. So negative 3 to the 5th. Negative 3 is raised to an odd power, so I know this is going to be negative. Negative 3 to the 9th. Again, 9 is odd, so I know this would be negative. Negative 3 raised to an even power is going to be positive. Negative 3 raised to 6, which is an even power, is also going to be positive. So negatives raised to odd powers are negative. Negatives raised to even powers are positive. And if you need to, you can just work it out step by step using the signs chart. Okay? So that's number 14. Let's go ahead and do number 15. '15 says if 6w plus 4 equals 8w, then 4w equals. So 6w plus 4 equals 8w. We can actually solve for w at this point by moving all the w's to one side and solving for w. So I can subtract 6w from both sides. This crosses out. I'm left with 4 equals 8w minus 6w is 2w. Let's divide both sides by 2 to get w by itself. This crosses out. I'm left with w equals 4 divided by 2, which is just 2. Okay, if w equals 2, then 4w equals 4 times 2, which is just 8. Pretty straightforward problem there. Okay, let's move on to number 16. 16 says 4y times 3x plus 2 minus 2 times 3x plus 2. To solve this one by factoring, you have to know how to factor by grouping, which means you have to pull out common factors. The common factor here is 3x plus 2. So if we pull that out, we can see what we have left is 4y minus 2. So as we can see, that matches this one. And again, this is factoring by grouping. This is actually a late stage of factoring by grouping, so I don't particularly like this problem. But all you do is factor out a 3x plus 2, and you're left with 4y minus 2 as the other factor. So that's all there was to that one. And that's all I have for you in this video. I hope you found it helpful. More often than not, the mathematics knowledge practice or subtest on the ASVAB is a lot easier than the arithmetic reasoning subtest. I hope you found that was the case as you took this practice test. Nonetheless, if you found my explanations helpful, feel free to give me a thumbs up and leave some positive feedback in the comment section below. In addition, I plan on adding at least a video every week until New Year's. So feel free to subscribe to my channel if you want new content. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.